So 8.2 is about graphing polynomial functions, and that's the only thing we want to do. We want to learn how to graph polynomial functions. And one thing is the way we plot, we graph is still the same. Where you have assume value for x, you get your y, then use those 2 points, you then use x and y to get your points, then you can use a point to plot your graph. Well, that's kind of what is, we're gonna have it as well. Okay, so now, but before that, so let's look at what we have here. Okay. So we have, if p of x is a polynomial function of degree n, the graph of the function as, so this is actually very important in this section, at most n real zeros and thus at most n x-intercepts, and also at most n minus 1 turning point. Okay, and don't forget the turning point is where your function actually changes from decreasing to increasing or increasing to decreasing. And that's where you have your relative maximum and minimum. Okay, so what is this talking about? This is just saying, for instance, now you have a polynomial x to the 4th power plus 3x cubed plus 2. For instance, let's say you have a polynomial, okay, f of x, okay? So let's say we have that. So now if they ask you, the number of real zeros and the x-intercept this is going to have, it's going to have at most 4, because the degree of this polynomial is 4. And that is what this is talking about. So it's going to have at most 4 real zeros and thus at most 4 x-intercepts. Then what about the turning point? The turning point will simply just be 4 minus 1, which is equals to 3. So it's going to have at most 3 turning points. Okay, and that is what that is talking about. Then we have some steps, that we can actually use to graph a polynomial function. Okay, so the first says that we can use the leading time takes to determine the end behavior. This is just, kind of give us some kind of hint. And we can find the zero of the function by solving f of x equals to 0. Okay, and that's gonna be your x-intercept. Okay, and also we can use the x-intercept as in our zeros to divide the x as into intervals and choose a test point in each interval to determine the sign of all function values in that interval. Like I said earlier, I said the way we plot graph, like your graph is the same. Okay, so this is just giving us where we can assume our x. Okay, and like we're gonna see all this in the example. Then also we can determine the multiplicity of the zero found in step 2 and make note of whether the graph we could also touch the x-axis at those places. And also we can find f of 0, okay, and that will give us our y-intercept. And if necessary, you don't have to do this. If necessary, you can find additional function values to determine the general shape of the graph and then draw the graph. And as a partial check, you can use the fact that you have at most n x-intercepts and at most n minus 1 turning points, to look at the x-intercept that you're gonna have and the turning point, okay? And you can confirm using a graphing calculator. Okay, all this are just giving us hint, and let's try to apply that in this following example. So we're told to graph the polynomial function h of x equals to negative 2x to the 4th power plus 3x cubed, okay? So the first thing we're gonna look at is the degree. So we're trying to look at the degree of this polynomial, which is 4, okay? So we're gonna use the leading time, to determine the end behavior. So we see that is 4, and when you look at this, when you look at 4, it's even. Okay, I said that it is even. You see that when we look at the coefficient, we see this is negative 2, right? which just give us hint that our graph should be this way, okay? So that's just give us hint for our graph is gonna be. So then after that, we can find the zeros as in solve h of x equals to 0. So we can try to, solve h of x equals to 0. So we're gonna have to set this to be equals to 0. So we're gonna have negative 2x to the 4th power plus 3x cubed, okay? Then we have to set this to 0. So now if we can try to factor what is common, okay? Don't forget, as you're setting this to 0, you're actually looking for the, for the x-intercept. So simply we are looking for the x-intercept. So now we're gonna try to bring out what is common, which is negative x to the 3rd power. Can bring that out. So when I bring out negative x to the 3rd power, so I'll be left with 2x, right? Such a way that when I multiply this, I'll get this. Negative x cubed times 2x will give us negative 2x to the 4th power, okay? Then I'll be left with 3 plus 3, okay? So now this will be negative 3. Let's see. This will be negative 3, okay? Such a way that when I multiply negative x cubed and negative 3, I should get plus 3x cubed, okay? So we're gonna be left with negative 3. And this is equals to 0, okay? And what does this mean? That simply means negative x cubed equals to 0. And this would imply that x equals to 0, okay? Then 2x minus 3 equals to 0. And this will imply you can add 3 to both sides. So you have 2x to be equals to 3. You have x to be equals to 3 over 2. So now we have x to be equals to 3 over 2. And at that point, what did we set to 0? H of x, which is more like your y. And like I said, that is your x-intercept. So simply we got x is equals to 0, x equals to 3 over 2. But at that point, your y is 0. So this is 0, this is 0, that you have x equals to 0, y equals to 0. And here you have x to be equals to 3 over 2 and y equals to 0. So those are our x-intercept. Those are the points we are going to use on the graph, okay? Then we're told that, to get other values, our x values, instead of just choosing any x value, we can try to choose, within this x-intercept. We can try to use our x-intercept to divide our x. So let's say we have here to be negative infinity to positive infinity, and this is our x, okay? So now I'm trying to use x0, so we're gonna have 0 first before 3 over 2. So I'm using that to divide my x. So, and I'm gonna choose my x within the x interval I have. So the first interval that you're gonna consider is gonna be from negative infinity to 0. So the next will be 0 to 3 over 2. And the next will be 3 over 2 to 1/2. 3 over 2 to positive infinity, okay? And that's the next thing we're going to do. Then now we can choose text value, which is gonna be your x, within negative infinity to 0, within 0 to 3 over 2, within 3 over 2 to positive infinity. And those are gonna be x values that we're going to kind of, use. So we're kind of assuming within these intervals that we have. So the first one, I choose -1. Okay, from 0 to 3 over 2, I choose this to be 1. And from 3 over 2 to positive infinity, I choose 2. Okay. Then after that, we're asked to find the function value h of x, which is more like your y. So now we can find h of -1, and that's what this is just saying. So we're gonna have -2 into -1 raised to power 4 plus 3 into -1 raised to power 3, okay? And when you work that out, you should get -5. Okay, so this will be -5. Just like I said, say the same way you assume value for x. So these are the text value, our x values that we actually assume. Then also we have to find h of 1. Okay, so we can find h of 1 which should be equal to -2 into 1 raised to power 4 plus 3 into 1 raised to power 3. And if you do that, you get this to be equals to 1, okay? Then another point that we have is 2, okay? We can find h of 2. So we can find h of 2. That will be equals to -2 into 2 to the 4th power plus 3 into 2 to the 3rd power. And then when you use a calculator for that, you get that to be equal to 8. So this is going to be 8. Okay, so now we're able to get some points, and the points that we're able to get from -5. Okay, we have 1, 1. Okay, then we also have 2, -8. Okay, so those are points we are going to use. Then we asked about the sign of h of x. Okay, so this is just saying the sign of this. So this is going to be negative, this is positive, and this is negative. And what does that mean? That's just telling us, you know, the position where our point is going to be, because if this is our h of x here is negative, so which means that we're going to be below x-axis. Okay, so we're going to be below x-axis, because don't forget, below x-axis is where you have the negative of your x, right? When you have this is negative, this is your x line, right? And this are negative y, this is a positive y. Okay, so now this is gonna be below x-axis. Okay, well, trying to make sure this fill into this space. Then this is plus, so that's gonna be above x-axis, and this is negative, so that's gonna be below x-axis. Okay, and that is what that is actually used for, so that you can know. Like I said, this is just giving us, you know, some hints now to, you know, the graph. Then after that, we have to determine the multiplicity of the zeros. Don't forget, we already got to the zeros by setting h of x to be equal to 0. So the zeros that we got were 0 and 3/2. Okay, those are the zeros, and they're also called the x-intercept. So now we're asked for the multiplicity. When you look at this, you see that when you the multiplicity of this 0, because this was what we set to 0 to get x equal to 0, is 3. And the multiplicity, this is more like raised to power 1, of this 0 is 1. Okay, so they both have odd multiplicity. So they both have odd multiplicity. So 0 has multiplicity 3. So we have that 0 has multiplicity 3, and 3/2 has multiplicity 1. Okay, so 1 and 3, they are odd. So which means that the graph is going to cross the x-axis at this 0. It's going to cross the x-axis at 3/2 and 0 and 0, 0, because this is a 0 anyway. So, and that is what that is just trying to tell us. So it's just giving us hints that at this 0, at 0, 0, and at 3/2, 0, and 3/2, 0, so the graph is going to cross the x-axis. So the graph crosses x-axis at this point. So it's going to cross the x-axis at those points. And we have to determine the y-intercept, okay? So the y-intercept is simply when your x is equal to 0. So you have x equals to 0, which simply means h of 0. And when you pull that into the graph, and into the function that was given to us, we have this. You see that that is going to be 0, right? So we're going to have that to be equals to 0. Or simply, I can write that how we have -2 into 0 raised to the power 4 plus 3 into 0 raised to the power 3, which is equals to 0. Okay? So we're simply confirming back that 0, 0, okay, it's a point, okay? When x equals to 0, y equals to 0. When y equals to 0, x equals to 0. Okay, so now number 6 is saying that we should try to find additional function values and draw the graph where you don't have to, okay? But if you want to, you can just try to look for some additional values. So like what I have here, x, you can find your h of x, which I didn't use. Like I said, you don't have to find all this, but if you want to, I have negative 0.5, which is negative 1/2, okay? And when you pull that, you're gonna get h of x to be negative. Then also, I have when x is 0.5, I got h of x to be equal to 0.25. And you can get more points. You can even use a calculator to get more points, okay? Then after you have all this, then you can try to sketch the graph, okay? Then, so this is more like a check. You can use that to check whether you know the number of x-intercept that you have, okay? So when you look at the degree of this polynomial is 4. When you look at this, this is 4. So that is just telling us we're going to have at most, we should have at most 4 x-intercepts. Doesn't have to get to that. It's possible you don't have up to that, but that's the most you can have. And at most n minus 1 turning point, which is going to be 4 minus 1, which is equal to 3. So you're going to have at most 3 turning points. So you're going to have at most 3 turning points. Okay. So now I have the graph here already. Well, I just showed the steps, so now we can get that. So, and these are the points, you know, used to plot the graph, as we can see. So we have this is 0, 0. We have the point 1, 1. We have 3/2 and 0. We have -1 and -5. We have 2 and -8. Just are the points that we actually got. Like I said, you at times you don't even need the additional point. So these are the points that we'll actually use. So we use this. We also use 0, 0, 3/2 and 0. And I think that's all the point. We didn't even use, like I say, this, you don't have to find the additional function values. Okay, you can draw the graph. If the points that you got from the test point, like the test value, and your x-intercept, y-intercept, the point you get from that, is sufficient enough to plot the graph. And you will know when you start plotting the graph. When you need more points, you will see that your graph, let's say you're plotting the graph and you get up to this point, then you'll be like, okay, I think I need to, you know, consider more points, see how the graph goes. Is it gonna go this way? Is it gonna go, you know? And that's how you can actually, I mean, it's gonna let you know what to do. And if you remember, we talk about multiplicity here. So we say that at 0, 0 and 3/2, 0, we say that it's gonna cross the x-axis. So now let's see, you will see that at that 0, it's gonna cross the x-axis. You see this? So this is just telling you that, you know, this is odd multiplicity. You can see at this point it crosses, you know, the x-axis, and at 3/2, 0, it also crosses the x-axis. And those are the x-intercept, right? Those are the x-intercepts, where it intercepts the x-axis, okay? And that's all about 8.2. Like I said, 8.2 is what we've done before. So we are just using the ints, like what we learned in 8.1, trying to use that. We can actually use that to, you know, to sketch our graph, or to know how our graph is actually going to look like, okay? And that's all about 8.2. So any question before I proceed to 8.3? So are we good to proceed to 8.3?
Yes.
Yes. Okay. Okay, thank you. So 8.3 is about polynomial division. Okay, so we want to look at the remainder theorem and the factor theorem. And we're going to look at long division. We are going to talk about syntactic. So we're going to use long division, syntactic, and, you know, remainder theorem. Okay, so before we actually do that, one thing we should remember, okay, or we should recall is when we divide a number, let's say we divide 6 by 2, we know that this is equals to 3, okay? And we know that there is no remainder, okay? So, and when they ask us, what are the factors of 6? 2 and 3, they're they're among the factors of 6, okay? And 2 times 3 will give us 6, okay? And so we can say that 2 is a factor of 6, 3 is a factor of 6, because when you divide 6 by 2, you have no remainder. The remainder you're going to have is 0, okay? But now, let's say we have 5 divided by 2, okay? 5 divided by 2 is 2, remainder 1, right? So we can say that 2 is not a factor of 5. And that's the logic here we're gonna try to see. Okay, so, but before we talk about that, you know, let's try to look at what we have here. So now let's say you were given h of x equals to x cubed plus 2x squared minus 5x minus 6, okay? When you factor this, you get x plus 3, x plus 1, x minus 2, okay? So this is the same thing. This function you have is the same thing as x. And the question here is, what are the factors? So the factors are simply what you have what this multiplied by this multiplied by this, just like exactly what I just said. 6 is the same thing as 2 times 3, right? 2 is a factor of 6. 3 is also a factor. So the factors here are x plus 3, x plus 1, and x minus 2, okay? They are factors of that. They are factors of that polynomial. And now we are asked, what are the zeros? The zeros are simply when you set the factor to 0, right? So simply the zeros, we're going to have the 0 when x plus 3 equals to 0, x plus 1 equals to 0, and x minus 2 equals to 0, okay? And from here, we can get x by itself by subtracting 3 from both sides. So we have x to be equal to negative 3. We can subtract 1 from both sides. We have x to be equal to negative 1. We can add 2 to both sides. We have x to be equal to 2, okay? So these are the zeros, okay? And one fact we know is the zeros that our x-intercepts, okay? And when you come to this graph, you confirm that. You see that x equals to negative 3. This is, you can see, is our x-intercept. You can see this is negative 1 is also our x-intercept. And you can see this is 2. This is also our x-intercept, okay? So that's more like a kind of review. Then let's try to go to the main objective. The first is to perform long division. So let's try to look at how to perform long division, okay? So now we want to try to divide, we want to try to determine whether x minus 3 and x plus 1 are factors of x cubed plus 2x squared minus 5x minus 6. If x minus 3 is a factor, then the remainder should be 0. if x minus 3 or x plus 1, if they are not factors, then that means we should get a remainder. So now let's try to do that. So now we have x minus 3. So this is a divisor. We call that divisor. Okay. Then what you have in here, I mean, in this looks like square, but it's not square. What you have in here is your dividend. Okay. The polynomial that you're trying to divide is a dividend, and our result is going to be our quotient. Okay. And whatever we get, if there is remainder, it's going to be our remainder, whether it's 0 or something else, it's going to be our remainder. Okay, so now let's try to perform the long division and see what we are going to get. Okay, so the long division is actually steps. Okay, so the first thing we have to do is we have to consider the first term that you have. Okay, and when you look at that, you look at the first term, and the first term outside what you're dividing with, you see that this is x cubed, this is x. So now you can say that x cubed divided by x. That will give us x to the second power. Okay. Then after doing that, the next step you have to do is you have to multiply this x squared by the divisor by x minus 3. And whatever you get, you're going to bring it down here. And that's what we're going to do now. So we're going to have x squared times x. That will be x to the third power. Okay. And then after that, we're going to say x squared times negative 3. That will give us negative 3x squared. So the next step after doing that is to subtract. You're going to subtract. Okay. So now you're going to have x cubed minus x cubed. This is out. So now this negative is affecting every time here. So you're going to have negative times negative here is going to be plus. So which means you're going to have 2x squared plus 3x squared. So this will give us 5x squared. Okay. So the next you have to do is you have to bring down the next term, because you must have at least, you must have at least 2. So you're going to have minus 5x. Then you do the same thing. You're going to say 5x squared divided by x, and that will give us 5x. Okay. Then after doing that, we have to use the 5x to multiply our divisor, which is x minus 3. So I'm going to have 5x times x. So that will give us 5x squared. Then I'm going to have 5x times negative 3. This will give me negative 15x. So now the next step is to subtract. Okay, so now we're going to have 5x squared minus 5x squared. This is out. This negative is also affecting this negative. Okay, so we're going to have negative times negative. So this is plus 15x. So simply we're going to have negative 5x plus 15x, and that will give us 10x. Okay, so the next is to bring this term, which is the last term. So we're going to bring negative 6. Okay, then I'm going to do the procedure again. 10x divided by x, that will give me 10. So now I have to use this 10 to multiply everything I have here. So I'm going to have 10 times x, that will be 10x. 10 times negative 3, that will be negative 30. Then I have to subtract now. Okay. So now that you subtract, I'm going to have 10x minus 10x, this out. Then we're going to have negative times negative. This is going to be 30. So we are going to have negative 6 plus 30, or simply 30 minus 6. So that's going to be 204. So this is the remainder. Okay, this is the remainder. Like I said, what you have here is your divisor. And what you have here, your answer when you divide, is the quotient. And this, the polynomial that you have, okay, this is that you're dividing, is the dividend. Okay, so now we can say that our remainder is 204. What does that tell us? It tells us that x minus 3 is not a factor of x cubed plus 2x squared minus 5x minus 6. That's what we have here. Since the remainder is 204 and not 0, then we know x minus 3 is not a factor. of x cubed plus 2x squared minus 5x minus 6. And that's how, you know, you deal with, that's how we have to do long division. So we're gonna go to the next example and see how we can do that. So I'm gonna erase this. Okay, so now we're going to compare the first term. This is x cubed, this is x, okay? So then we have to say x cubed divided by x. So that will give us x to the second power, okay? X to the second power times x, because we have to use that x squared to multiply our divisor. So x squared times x, that's x cubed. X squared times 1, that will give us plus x squared. Then the next step for you is to subtract. So now we're going to have x cubed minus x cubed this out. Then don't forget this negative is affecting this as well. So you're going to have negative times plus a squared. So simply you're going to have negative a squared. So we are going to have 2a squared minus a squared. And that's going to give us x squared. So now I have to bring this down, minus 5x. Okay. So now that we have two terms, so we have to, you know, do the procedure again. A squared divided by x, that will just give us x. Okay, now I'm going to use this x to multiply my divisor, to multiply everything I have here. So I'm going to have x times x, that will give me x to the second power. X times 1, that will give me plus x. Then I have to subtract. Okay, so now I'm going to have, x squared minus x squared, this is out. Then this is negative times 4, so this is negative x. So we're going to have negative 5x, negative x, so we're going to have this to be negative 6x. So now I'm going to bring this last term, so we're going to have minus 6, okay? So I'm going to do the procedure again. Negative 6x divided by x, that will give us negative 6, okay? Now I have to use this negative 6 to multiply everything I have here. So we're going to have negative 6 times x, this will be negative 6x. Negative 6 times 1, this will be negative 6. Okay, so the next is for you to subtract. Okay, even from here, you should be able to see that that should be 0. Okay, we're going to have negative 6x. So this is negative times negative, that's plus 6x. So negative 6x plus 6x is 0. So we have negative 6, then you have negative times negative, that's plus. So we have negative 6 plus 6, that's 0. So you can see that the remainder, it's 0 minus 0 is just 0, okay? The remainder is 0. So this is the remainder. Okay, that's the remainder. This is our quotient. This is our quotient. This is our dividend. This is our divisor. Okay, so since the remainder is 0, then we know that x plus 1 is a factor. Okay, and that is how, you know, to do long division. Okay, any question on that before I proceed? No question.
No.
Okay, thank you. So now we have some facts here before we proceed to the remainder theorem, okay? So now we have that when dividing a polynomial p of x by a divisor d of x, a polynomial q of x is a quotient and a polynomial r of x is the remainder, okay? And that's what we just analyzed. So the quotient must have degree less than that of the dividend, okay? And the remainder must either be 0 or have degree less than that of the divisor. So this is just trying to, you know, tell us some fact. I mean, it's not going to be possible for you to divide if you have x squared, you know, you're dividing by x to the 5th power. I mean, it's not going to be easy for you to do that. But let's say you have the degree of your numerator is x to the 10th power, It's kind of easy, you know, and that's what they're just trying to tell us. And they're saying that your device is, your remainder should be 0, or degree should be less than that of the divisor. Okay, so that's just the statement. Okay, then but there's another fact here. Okay, our p of x, which is our polynomial, that's our dividend. Okay, and d of x, which is your divisor, that's our divisor. Then our q of x, which is our quotient, our r of x, our remainder, they're all polynomials. Okay, so we can actually write any polynomial in this form. You can write it in a way that you can say your dividend p of x is equals to d of x, which is your divisor, multiplied by q of x plus r of x. So you can write that. And we'll try to verify that. And that is the next thing we are going to do. So this is right. So this is more like a fact. Our p of x is equal to d of x multiplied by q of x plus r of x, and everything is actually defined here. You know what your d of x is, you know what your q of x is, you know what your r of x is. So we want to try to check. Okay, so we want to verify that p of x is actually equals to d of x multiplied by q of x plus r of x. Okay, so now this is our p of x, x cubed plus 2x squared minus 5x minus 6. And we have our d of x to be x minus 3. We have our q of x to be x squared plus 5x plus 10. And we have our r of x to be 204. So we want to confirm that d of x multiplied by q of x plus r of x will give us this. Okay, and so we're going to use all those terms. So d of x, our d of x is x minus 3. Then multiply by q of x. Our q of x is x squared plus 5x plus 10. Then plus r of x plus our r of x is 204. We want to see if we are going to get this, which is our p of x. So we can try to fold this. So we're going to have x times x squared. That will be x cubed. X times 5x will give us plus 5x squared. Then x times 10 will give us plus 10x. So we're going to have negative 3 times x squared will give us negative 3x squared. Negative 3 times 5x will give us negative 15x. Negative 3 times 10 will give us negative 30. And then we're going to bring this plus 24. Okay, so let's try to collect like terms. So we cannot pair x cubed with anything. So I'll just bring x cubed down. So we have 5x squared minus 3x squared. So that will give us 2x squared. Then after that, we have 10x minus 15x. That gives us negative 5x. Okay, then after that, we have negative 30 plus 24, which is negative 6. And you see that this is exactly equals to p of x. Okay, and that's, you know, like I said, this is actually the fact. And that's going to help us with what we called the remainder theorem. Okay, so now we're going to proceed to the remainder theorem. What does the remainder theorem say? Okay, so the remainder theorem says that if a number c is substituted for x in the polynomial f of x, then the result f of x is the remainder that will be obtained by dividing f of x by x minus c. That is, if f of x is equals to x minus c dot q of x plus r, then f of c is equals to r. Well, let's see, what are they trying to say here? You're just trying to tell us that now this is your divisor. If x minus c is your divisor, and you find f of c will give you the remainder. Okay, so now let's try to see that in a more, this is kind of abstract, you know, in a more practical way. Let's try to see. So now let's say we want to find f of c. They say if a number c is substituted for x in the polynomial. So let's try to see. Let's say we have our f of x, and our x minus c is our divisor, x minus c. Okay, c is a constant, can be any number, dot q of x which is our quotient plus r. So now let's substitute x for c. So let's say we have our x equals to c. You will see that we're going to have x. So this is going to be c minus c, right? Q of x, we're going to have this to be q of c, then plus r. What happened? C minus c. 0 multiplied by q of c plus r. And this will be simply 0 plus r. And that is equal to the remainder, okay? And that is what the remainder is actually telling us, that if your x is substituted for c, your f of c is going to be exactly your remainder, whatever you get. And we're going to try to see that. Okay, so let's try to see that from what we did in the previous example. Let's see. So I'm going to go to the previous example. Let's look at what we have. So in the previous example, because when you look at this, it's still the same polynomial that we have from the example that we did. So let's go up. So you see that we actually try to divide, x cubed plus 2x minus 5x minus 6 by x minus 3 and x plus 1. So I'm going to bring that down, x minus 3 and x plus 1. So we have x minus 3 and x plus 1, okay? And don't forget it said x minus c, okay? If a number c is substituted for x in a polynomial f of x, then the result f of x is the remainder that will be obtained by dividing f of x by x minus c. It has to be in that form, x minus c. So now if I have x minus c, if I compare that with x minus 3, so I'm going to go with this first, I can compare this and see that my c is equals to 3. Okay, and that's why they're trying to tell you find f of 3. Okay, so now if we find f of 3, we are going to get the remainder that we got when we divided by x minus 3 in the previous example, and we're going to see that. So this is simply 3 raised to power 3 plus 2 into 3 squared minus 5 into 3 minus 6. Put that in the calculator, you get 24. Okay, you can try to put that in the calculator. And that's exactly the remainder that we got when we divided, when we use the long division. You see, that's exactly the remainder. This was the remainder that we got. Okay, and that's what the remainder theorem is talking about. And we're going to try again for x plus 1. So now for x plus 1, I have to make sure it's of the form x minus c. Okay, so I can rewrite x plus 1 to be equals to x minus 1, right? Okay, so that it's going to look like x minus c. And if I do that, you see that my c is going to be -1. Okay, you have to have x minus. So you see c is -1, which simply means f of -1. Okay, so if I find f of -1, I should get exactly the remainder when I divide it by x plus 1 or x minus 1, which is the same thing as x plus 1. Okay, and that is what the remainder is trying to tell us. So this will now be equals to -1 raised to power 3 plus 2 into -1 squared minus 5 into -1 minus 6, and this will be 0. That will give you exactly the remainder that we've got when we divided by x plus 1. Okay, so you can use the calculator to confirm that. Okay, and that is what the remainder is actually, telling us. And for instance, down in my labs, if they ask you to find the remainder, you don't have to use the long division. Okay, so you can just, try to find your c. F of c will give you the remainder. Okay, but if they ask you to find the quotient, then you might not want to use it because you need to find the quotient. You need to find the quotient. The remainder theorem is only going to help you just for the remainder. Okay, and that's about remainder theorem. Any question before we go to syntactic division?
No questions.
Okay. Okay, thanks. For syntactic division, we have some steps here, but I'm gonna go through the step. So you can go through this later on. But I'm going to apply the steps in the examples. Okay. So the first example that we have, we're asked to use syntactic to find the quotient and the remainder. So we are given 2x cubed plus 7x squared minus 5 divided by x plus 3. Okay. So one thing about syntactic division, your divisor also has just 1 degree, like has to be degree 1. Okay. Cannot be greater than that. Okay, so that's one thing you should know. If it's greater than that, then you have to use the long division. So the first step for syntactic is we have to try to rewrite this polynomial, our dividend, and make sure we replace any missing term with 0. Okay, this is our dividend. Okay, so we have to make sure that we write any missing term with 0. What does that mean? So I'm going to rewrite this. So have the polynomial to be 2x cubed, okay, plus 7x to the second power. So you can see that the x term is missing, x to the 1 power is missing, so I'm going to have a 0x, which is more like 2x to the power 1, okay? I mean, what you don't have, most of the time we don't put that when it's raised to the power 1. Then after that, we can have the constant -5, okay? Okay, so now after I'm done, writing this, I have to write out the coefficient. Okay, for the syntactic, what we use is just the coefficient. So I'm gonna write 2. After 2, I have 7. After 7, I have 0. And after 0, I have -5. Okay, and I'm gonna be we are dividing that. This is our divisor, x plus 3. Okay. So when we use syntactic, what we use is our c. So I have to compare this to x minus c. So now I have to rewrite x plus 3. So my x plus 3 will be x minus -3. Such a way that when I compare with x minus c, -3 will be my c. So my c will be equal to -3. And that is what I'm going to have here. So I'm going to have -3 here. Okay, so now after we're done with that, the next step that we have to do is we have to drop the first number that we have here. We have to bring it down. We have to drop the coefficient, the first one. Then after we're done with that, then we have to multiply 2 by -3. The number you drop, you have to multiply by your c. So 2 times -3 give us -6. So now you have to add 7 minus 6, this will give us 1, okay? So now you have to use this 1 to multiply the c again, 1 times -3, then you have to write it here, this is -3, okay? Then after that, you add 0 minus 3, so this will give us -3, okay? Then after that, the next is to use this -3 to multiply your c. So -3 times -3, that gives us +9. Okay, so I'm going to add again. So I have -9 plus 9. So this gives me -4. Okay, and according to the syntactic, the last that you're going to have here is going to be your remainder. Okay, and what you have here is going to be the coefficient of your quotient. Okay, so now the step, when you go through the step, one of the steps says that, when you have this to be to the 3rd power, your answer has to be reduced by 1 power. Okay, in syntactic, when you look at the degree of the polynomial, if it's raised to power 3, then your answer has to be reduced by 1. So which simply means if I want to write a quotient, I'm going to have this to be 2x to the 2nd power. So the next will be plus x, because this is 1x, then -3. So that's my quotient. So that will give us the quotient. And that's how to use the syntactic. Okay, and that's the steps for syntactic. So I'll proceed to the next example. So the next example, we also want to use syntactic to find the quotient and the remainder. Okay, So now I'm going to rewrite this. So we're going to have 2x to the fourth power. The x cubed is missing because this is x to the second power. So I'm going to have 0x to the third power. Then now I can have 3x to the second power. Then, excuse me, x1 power is also missing. So I'm going to have plus 0x, then minus 1. Okay. So I'm going to rewrite all this. I'm going to write all the coefficients. So we have 2, we have 0, we have 3, we have 0, we have -1. Okay, so I'm going to get my C. When you look at this, you see that x minus C, that's what we're comparing this to the divisor. So you can see that our C is exactly 1/2, right? So we're going to have here to be 1/2. Okay, so now the next step is to bring down the 2. Okay, then we have to use the 2 to multiply 1/2. So 2 times 1/2 will give us 1. Okay, so 0 plus 1, that's 1. So we're going to have 1 times 1/2, that will give us 1/2. Okay, so simply we have 3 plus 1/2, which is the same thing as 7/2. So which is the same thing as 7/2. Okay, then the next is 7/2 times 1/2. That will give me 7/4, 7/4. Okay, and 0 plus 7/4, that will give us 7/4. Okay, then 7/4 times 1/2, that will give us 7/8. Let me make this a bit smaller, so I'm going to add space. So that will give us 7/8. Okay, so -1, wait, let me write it well, 7/8. So -1 plus 7/8, that will give us -1/8. Okay, and that is exactly our remainder. That's our remainder. Okay, and these are the coefficients of the quotient. Okay, so this started with x to the fourth power. Our quotient is going to be reduced by 1. So we are going to have 2x cubed plus, this is 1x squared. So simply I'll just put x squared, then 7 plus 7/2x, then plus 7/4, which is a constant term. And that's going to be the quotient. Okay, so this is our quotient. Okay. So, and that's how to do syntactic. So any question on that before we proceed?
No.
Okay, thank you. So now we're given that f of x equals to 2x raised to the power 5 minus 3x to the fourth power plus x cubed minus 2x squared plus x minus 8. Okay, and we asked to find f of 10. Okay, so we all know that finding f of 10, we just need to replace x with 10. And whatever you get is actually, if you remember, this is more like your C, is exactly you dividing by x minus 10. Okay, when you divide this polynomial by x minus 10, the remainder that you will get is the same thing as when you find f of 10. Okay, so now let's try to find f of 10. We can also use syntactic. So this is going to be equal to 2 into 10 raised to the power 5 minus 3 into 10 raised to the power 4 plus 10 raised to the power 3 minus 2 into 10 raised to the power 2 plus 10 minus 8. Okay, so when you use a calculator, you should get 170802. That's what you should get. And we can try to use syntactic. Okay, so because this is exactly your C. Okay, so that's what we're going to use divide if we use syntactic. So when you look at all these terms, there's no term that is missing. We have all the terms complete. I'll just write down the coefficient. So we have 2, we have -3, we have 1, we have -2, we have 1, and we have -8, okay? Then my C, like I said, is exactly what you have here. So your C is 10. Okay, so we can try to, use syntactic and see what we get. So this, will I have to bring this down. So this is 2. 2 times 10, that's 20. -3 plus 20, that's 17. 17 times 10, that will give us 170. So 1 plus 170, that's 171. 171 times 10, that will give us 1710. Then -2 plus 1710 will give us 1708. Okay. Then 1708 times 10, that will give us 17080. Okay. Then 1 plus 17080 will give us 17081. Okay. So 17081 times 10, we are going to get 170,810. Okay, then -8 plus 170,810 will give us 170,802, and this is exactly our remainder. Okay. Okay. So that's exactly our remainder. Like I say, you're not asked to find the quotient here, so this is just your quotient, but we can write that down. So simply, this is to the 5th power. Our answer has to be reduced by 1. So we're going to have this to be 2x to the 4th power plus 17x cubed plus 171x squared plus 1708x, then plus 17081. So that will be the quotient. Like I said, we're not asked to find the quotient, but we can write that down. Okay. And that's for this example. Okay. So after that, we can go to the next example. So the next example that we have, we want to determine whether 5 is a 0 of g of x. Okay, so I'm going to erase this. Okay, so we want to determine if 5 is a 0. So if we can remember, we can recall, that just simply means we should replace x with 5. And if we get a 0, then 5 is a 0. Okay, so simply we want to find g of 5, which should be equals to 5 raised to the power 4 minus 26 into 5 squared plus 25. Okay, so if you use a calculator, you get 0. That's what I got, get 0. So this means that g of 5 equals to 0. And what does that tell us? That just tells us that 5 is a 0 of g of x equals to x to the 4th minus 26 x to the 2nd plus 25. Okay, that's exactly what I meant. Okay, so now we're gonna come back here. So now let's try to look at what the factor theorem tells us. Okay, so now we have what we call the factor theorem. Okay, so the factor theorem states that for a polynomial f of x, if f of c is a 0, like if f of c is equal to 0, then x minus c is a factor of f of x. Okay, that is, if x minus c is a factor, then c is a 0. If c is a 0, then x minus c is a factor. Okay, so simply, we have 5 is a 0 of g of x. That means that x minus 5 is a factor. It's a factor of this g of x. It's a factor of this polynomial. Okay, and that is what the factor theorem is actually telling us. Okay, and let's say you're told that x minus 5 is a factor, then you should know that 5 is a 0. Okay, and let's try to look at what we have here. So we're given y equals to x cubed plus 2x squared minus 5x minus 6. And it's the same thing as f of x. I mean, you can replace that with f of x. Okay, it's the same thing. So when you factor this, you get x minus 2, x plus 3, x plus 1, okay? So it is true that negative 3 is a 0 of f, okay? Because when you set this to 0, you have x plus 3 equals to 0, then you have x to be negative 3, okay? It is true that negative 3 is a 0, or even if you don't do that, just put negative 3 into this function, okay? Negative 3 plus 3 is gonna be 0, and everything will be 0, okay? So it is true that negative 3 is a 0, okay? It is also true that f of negative 3 is equal to 0. It is also true that negative 3 is a solution of f of x equals to 0, because when you set f of x to be equal to 0, when you set this to be equal to 0, so you will get negative 3. So negative 3 is a solution of f of x equals to 0. And also, negative 3 comma 0 is an x-intercept of the graph, okay? And 0 is the remainder when f of x divided by x minus minus 3, which is simply x plus 3. 0 is a remainder. 0 is a remainder because you know that x plus 3 is a factor. Okay, and that is what they abbreviate to x minus minus 3, which is simply the same thing as x plus 3 is a factor of f. Okay, and that's exactly what we have for this. If 5 is a 0, x minus 5 is a factor, 5 comma 0 is an x-intercept. Okay, and that's what, you know, the factor theorem is actually telling us. So from 1, we should be able to predict order. If they tell you 5 is a 0, then 5 is an x-intercept. 5 is also a solution of that function. And x minus 5 is a factor. Okay, and that's all we have for 8.3. And next week, we're going to start with 8.4. So any question?